Right now, at this very moment, there is a machine flying through the darkness between the stars. It is not orbiting anything. It is not waiting for a command to begin its mission. Its mission, in the way we originally designed it, is essentially over. And yet it is still moving, still drifting outward, still carrying a small piece of human civilization into a void so vast that the numbers we use to describe it lose all meaning. This machine is called Voyager 2. It launched in 1977. That means it has been traveling without stopping, without refueling, without a single human touch, for nearly 5 decades. And the question that keeps scientists, engineers, and philosophers up at night is not where it is going, because we already know the answer to that. Nowhere specific, just outward. Forever, the real question is far more unsettling. When does it die? And what does it even mean for something like Voyager to die? Because here is the thing most people do not realize. Voyager 2 will not go out with a bang. There will be no explosion, no crash, no dramatic final moment. Its death will be something far stranger and far more haunting than that. It will be a silence, a slow, inevitable silence spreading across billions of miles of empty space. Until one day, engineers on Earth send a signal and wait, and nothing comes back. And the event in Voyager 2 will still be out there, still moving, still carrying its golden record into the dark, long after every person alive today is gone, long after the civilization that built it has been transformed beyond recognition. That is the story of Voyager 2. Not just what it did, but what it is still doing, and what it means when a machine we built and launched and spoke to for 50 years finally stops speaking back. To understand where Voyager 2 is going, you need to understand where it came from. And more importantly, you need to understand what it was never supposed to become. When engineers at NASA designed Voyager 2 in the early 1970s, the goal was stunning but finite. A rare alignment of the outer planets, something that only happens once roughly every 175 years, made it possible to send a single spacecraft on a grand tour. Jupiter, Saturn, Uranus, Neptune, one after another, using the gravitational pull of each planet as a slingshot to accelerate toward the next. It was one of the most elegant pieces of orbital mechanics ever conceived, and it worked almost perfectly. Voyager 2 gave humanity its first close-up view of the rings of Uranus, its first detailed images of Neptune's stormy blue atmosphere, its first real look at the giant moon. Triton with its geysers of nitrogen ice shooting up from the surface like something out of a science fiction novel. These were not incremental discoveries. They were genuinely new chapters in human knowledge, written by a machine the size of a small car, traveling through a place no human had ever been, and likely never will be in any of our lifetimes. But here is what makes Voyager 2 different from almost every other spacecraft ever launched. After Neptune, it did not stop. There was no planet left to visit, no target on the mission calendar, no specific scientific objective waiting on the other side. There was just space, and Voyager 2 kept going into it. Over the following decades, it drifted further and further from the sun, slowly moving away from the orbital plane where the planets circle, angling downward through a region of space that gradually thinned and changed. The solar wind, that constant stream of charged particles blowing outward from the sun, grew weaker. The familiar electromagnetic environment of our solar system began to fade. And in 2018, something remarkable happened. Voyager 2 crossed the heliopause. The heliopause is not a wall you can see or a line on a map. It is the boundary where the sun's influence essentially ends, where the solar wind is finally overwhelmed by the interstellar medium, the thin, ancient material drifting between the stars. Crossing it means Voyager 2 became only the second human-made object in history to enter true interstellar space. Its twin, Voyager 1, had crossed 6 years earlier. Together, they are the furthest things humanity has ever sent anywhere. And from that boundary, Voyager 2 is still moving outward today, sampling a region of space that no probe, no telescope, no instrument of any kind has ever directly measured. It is touching a part of the universe that existed long before our sun formed, that stretches between stars in a near silence, and it is sending back data about what it finds there. That is the miracle of it. That is the part that feels almost impossible when you sit with it long enough. But miracles have power sources, and Voyager 2's power source is running out. The spacecraft does not use solar panels. Out beyond Neptune, sunlight is so faint, so diluted across billions of miles, that solar panels would be essentially useless, capable of generating barely a fraction of the energy needed to run even the most basic systems. Instead, Voyager 2 runs on something called a radioisotope thermoelectric generator, or RTG. It is a device that contains a small amount of radioactive plutonium-238. As the plutonium decays, it releases heat. That heat is converted directly into electricity. No moving parts, no combustion, no fuel tank that can run dry in the traditional sense. It is an elegant system, and it was designed specifically for deep space missions where the sun is too far away to be useful. And it has worked beautifully, far beyond what anyone originally anticipated. But radioactive decay is relentless, and it only moves in one direction. Every year, Voyager 2's RTG produces a little less power than the year before. Not a dramatic drop, but a slow, steady decline of a few watts annually. A few watts sounds trivial until you realize that Voyager 2 is operating on an energy budget so tight that the difference between one instrument staying on and going dark can be a matter of watts. When Voyager 2 launched, its RTG was producing around 470 watts of power. By now, that number has dropped to somewhere in the neighborhood of 70 watts or less. To put that in perspective, a standard incandescent light bulb uses 60 watts. Voyager 2 is running an entire interstellar spacecraft, maintaining communications across billions of miles, keeping sensitive scientific instruments alive, heating its electronics against the near absolute zero temperatures of deep space, all on roughly the equivalent of a single household light bulb's worth of electricity. That is not just impressive engineering, that is a kind of miracle. But even miracles have ceilings, and the ceiling for Voyager 2 is getting very close. The mission team at NASA's Jet Propulsion Laboratory has been managing this energy decline for years, making decisions that have no easy answers. Every time they need to save power, they have to choose what to sacrifice. The cameras went dark long ago. Various scientific instruments were powered down one by one as the electricity budget shrank. More recently, NASA made the difficult decision to turn off a science instrument that was still functioning and still collecting data. Not because it had failed, but because keeping it running would have risked losing power to the systems that keep the entire spacecraft functional. That is the brutal arithmetic of Voyager 2's survival. To keep it alive at all, you have to keep letting parts of it die. This is where the concept of death gets complicated, and where the story of Voyager 2 becomes less like an engineering problem and more like something philosophical. Because Voyager 2 is not going to die once. It is going to die in layers. The first death is happening gradually, right now. It is the death of Voyager 2 as a scientist. For decades, the spacecraft has been doing something genuinely irreplaceable. It has been sitting in interstellar space, directly measuring the properties of an environment that no other instrument can reach. The density of particles between stars, the strength and direction of magnetic fields beyond the sun's protective bubble, the behavior of cosmic rays in their natural habitat before they are deflected or altered by solar influence. This data is not just interesting. It is unique. There is no other way to get it. No telescope on Earth, no satellite in Earth orbit, no probe in the inner solar system can tell us what Voyager 2 knows simply by being where it is. But as power continues to decline, the last remaining science instruments will eventually go dark. One will fail or be turned off to preserve power, and then another. At some point, Voyager 2 may have just enough electricity to maintain basic systems and communication, but not enough to power any meaningful scientific measurement. When that happens, 50 years of continuous interstellar exploration will simply end, and the universe that Voyager 2 has been quietly documenting will go unobserved once more, at least until another mission, if one is ever built, can reach that distance. The second death is more emotional, at least for the people who have devoted their careers to this spacecraft. It is the death of communication. The moment Voyager 2 goes silent, think about what that communication actually looks like today. When engineers at the Deep Space Network send a signal to Voyager 2, that signal travels at the speed of light, the absolute speed limit of the universe. the fastest anything can possibly move. And even at that speed, the round trip takes more than 18 hours. You send a command and you wait almost an entire day for the confirmation that it was received. There is no real-time interaction. There is no ability to react quickly if something goes wrong. Every exchange is a slow, deliberate act of patience that spans nearly 3/4 of a day, and the signal that comes back from Voyager 2 is unimaginably faint. By the time it crosses the billions of miles between the spacecraft and Earth, it is spread out so much that it carries less than a millionth of a billionth of a watt of power. The Deep Space Network antennas, enormous dishes up to 70 meters across, are straining to hear it. They are not listening to a voice. They are detecting a whisper so quiet that any interference, any noise in the system, any moment of input could swallow it entirely. Now imagine that whisper getting quieter every year. As the RTG fades and the transmitter has less power to work with, and as the distance continues to grow, spreading that signal thinner and thinner across an ever larger sphere of space. There will come a day when the signal simply falls below what our instruments can detect, or a day when a critical component on board, a transmitter, AN, antenna motor, a timing circuit, fails and cannot be repaired by anyone, because the repair crew is 1 billion miles away and there is no ship to send. On that day, engineers will send a command and wait. They will try again. They will adjust their receivers, point the antennas more precisely, listen harder, and eventually, the silence will become undeniable, not with a bang, not with a farewell transmission, but with an absence, a gap where a signal used to be. That will be the moment Voyager 2 dies to us, the moment the conversation ends. And the strange, almost unbearable part is that we may not know it is the final signal when we receive it. There may be a last packet of data streaming in right now, or sometime in the 2030s, and the engineers analyzing it will have no idea that they are looking at the last words. Voyager 2 will ever send. Only later, when the waiting stretches on and the silence refuses to break, will they understand what they witnessed. But here is the part that changes everything. Here is the part that makes Voyager 2 unlike almost any other object humanity has ever made. After the power is gone, after the transmitter is dead, after the instruments have frozen in the absolute cold of deep space, and every electronic system aboard has failed permanently, Voyager 2 will keep going. There is almost nothing in interstellar space to stop it. No atmosphere, no friction, no magnetic braking, no gravitational tug strong enough to significantly alter its course over human time scales. The spacecraft will simply drift, following the path its velocity set for it, carrying forward the momentum it built during those planetary flybys. Nearly half a century ago, it will become, in a very real sense, a ghost. A dead machine still traveling, still moving through the galaxy at roughly 55,000 kilometers per hour. Going absolutely nowhere in particular, but going there for an almost incomprehensible amount of time. The timelines involved here are the point where the human mind starts to give out in approximately 40,000 years. Voyager 2 will drift close to a dim red star called Ross 248, passing within about 1.7 light-years of it. That is not a flyby in any dramatic sense. It will not swing around the star, will not be captured by its gravity, will not produce any observable event. It will simply be the closest Voyager that gets to another sun after leaving, our own. And at that point, our sun, the star that gave birth to every atom in every human body who's ever lived, will be just another dim light among thousands, indistinguishable from the rest of the stellar background. In about 296,000 years, Voyager 2 will pass within 4.3 light-years of Sirius, the brightest star in Earth's night sky. In millions of years, its trajectory may carry it into the outer fringes of other star systems, close enough to feel their gravity, not close enough to be captured. In hundreds of millions of years, if nothing intercepts it and no collision destroys it, Voyager 2 may still be intact, drifting through some part of the Milky Way that no human has ever named, carrying a golden record engraved with the sounds and images of a civilization that launched it on a warm August day in 1977. By the time Voyager 2 drifts near Ross 248, our languages will be unrecognizable. The nations that funded its construction will exist only in history records. The engineers who built it the scientists who planned its trajectory, the technicians who assembled it by hand. All of them will have been dust for tens of thousands of years. And still, somewhere in the dark, the spacecraft they built will be moving. There is something on board Voyager 2 that makes all of this even more surreal: the Golden Record. Both Voyager spacecraft carry one. It is a gold-plated copper disc containing sounds and images selected to represent the diversity and vitality of life on Earth. There are greetings in 55 human languages. There is music from dozens of cultures, from Bach to Chuck Berry to a Peruvian wedding song to a piece of Azerbaijani folk music. There are sounds of wind, rain, surf, thunder, and birdsong. There are images of human beings, human structures, human biology, human science. There are mathematical and physical constants designed to help any recipient understand the context. Dere is a map showing the location of our sun relative to nearby pulsars, so that whoever finds it, if anyone ever does, can trace its origin back to a specific point in the galaxy. Carl Sagan, who championed the inclusion of the Golden Record, called it a bottle cast into the cosmic ocean. The chance that it will ever be found is vanishingly small. Interstellar space is almost incomprehensibly empty, and the odds that Voyager 2 will drift close enough to any inhabited world, in a galaxy with hundreds of billions of stars, and an age measured in billions of years, are effectively zero. On any time scale we can reasonably contemplate, but that is not really the point. The point is that the record exists. The point is that human beings, standing on a small rocky planet orbiting an ordinary star in the outer suburbs of an average galaxy, decided to put a message in a bottle and throw it as far as they possibly could. Not because they expected an answer, not because the math made it likely, but because the impulse to reach out, to say, "We were here," to leave some trace of ourselves in a universe that does not care about us at all, is one of the most deeply human impulses there is. When Voyager 2 finally goes silent, when the last signal fades and the engineers close their receivers and the mission officially ends, that Golden Record will still be out there, still intact, still carrying Bach and birdsong and the brainwaves of a young woman in love, all encoded in grooves on a disk that could theoretically survive for billions of years in the cold vacuum of space. It is the longest lasting thing we have ever made, the most durable message, the longest possible bottle, and it will outlive not just the people who made it, but almost certainly the civilization that produced them. The people who work on Voyager to know all of this. They live with it every day. These are scientists and engineers who have in some cases spent their entire professional careers listening to a spacecraft that launched before they were born, coaxing a few more watts out of dying systems, interpreting data from instruments that were built before personal computers existed, extending a mission that was supposed to end at Neptune into something that has become the longest space mission in history. There is a particular kind of intimacy in that work. You do not spend decades listening to something, worrying about it, celebrating its triumphs, and mourning its losses, without developing a relationship with it that is hard to describe rationally. Voyager 2 is a machine. It has no consciousness, no preferences, no awareness of the dark it is traveling through. But the people who tend to it have given it something like a life in the way they talk about it and care for it. They speak of its health, its warmth, its memory. They make sacrifices to keep it functioning that cost them real scientific opportunities. They stay up late listening for a signal that travels for 18 hours just to reach them. When Voyager 2 finally goes quiet, those people will grieve, not irrationally, not foolishly, but in the way you grieve when something that has been part of your life for as long as you can remember is suddenly gone, and the universe will not notice. The darkness between the stars will be exactly as dark as it was before. The interstellar medium will drift on, measured now only by silence, but we will notice, and that noticing is what makes us human. So when does Voyager die forever? The honest answer is that it depends on which version of death you are counting. As an active mission, it likely has somewhere between 5 and perhaps 15 years remaining, depending on how carefully the power is managed, how well the systems hold up, and whether engineers can find new ways to squeeze efficiency out of hardware that was never designed to survive this long. NASA has already extended the mission multiple times by turning off heaters, powering down instruments, and routing electricity through backup pathways that were never part of the original design. Every extra year of operation is a genuine engineering achievement, hard-won from a spacecraft that has already exceeded every expectation ever set for it. As a scientific instrument, it may have less time than that. The instruments that are still operating are valuable, but they require power that is increasingly precious. The day when Voyager 2 can no longer run any useful science is approaching faster than the day when it can no longer communicate at all. As a communicating object, a voice in the dark, it may persist somewhat longer, sending engineering data, basic telemetry, proof of existence, even after science has ended. But that signal too will eventually fall below the threshold of detection, either because the transmitter lacks power or because a critical system fails and cannot be reset from 18 hours away. And as a physical object, a dead spacecraft drifting through the Milky Way, it may persist for longer than the human mind is capable of truly imagining. Billions of years, potentially. Long after our sun has swollen into a red giant and consumed the inner planets. Long after Earth, Ibitsur Vivis has been sterilized and transformed into something unrecognizable. Long after every human language, every human memory, every human monument has crumbled into dust and been recycled by geological and stellar processes into something entirely new. Voyager 2 will still be moving. There is a strange comfort in that, if you let yourself feel it. We are a species with a very short life expectancy by cosmic standards. Our sun has about 5 billion years left. Complex life on Earth has existed for perhaps 600 million years. Human civilization is maybe 10,000 years old. Our written language is barely 5,000 years old. Spaceflight is less than 70 years old. We are new here. We are brief. We are fragile in ways that the universe does not concern itself with. But we made something that will outlast us. In all likelihood, Voyager 2 will still be intact and moving long after every other physical trace of human civilization has been erased. The pyramids will be sand. The cities will be geology. The books will be carbon, but a machine we built with our hands, guided by our mathematics, and launched from our small blue world, will be somewhere in the galaxy, still carrying the sounds of our voices, still carrying the music we loved, still carrying a map home. There is something in that which feels important. Not triumphant, not comforting in a simple way, but important, like a reminder that the things we make and the effort we pour into reaching beyond ourselves matters, even in a universe that is so vast and so indifferent that we can barely exist as a rounding error in its equations. Voyager 2 will not die forever. It will die to us. Yes, the conversation will end. The signal will fade. The mission will close. But the spacecraft itself will drift on into a future so remote that we cannot picture it, carrying the fact of our existence into a darkness that will swallow everything else we have ever made or thought or hoped or loved. And somewhere out there, right now, it is still moving, still sending, still crossing the gulf between the stars one slow kilometer at a time. The last signal has not come yet. The conversation is still open, and every moment that it stays open is a small defiant miracle. Built by human hands and launched into forever on a summer day in 1977 by a species that decided, against all practical logic, that the darkness was worth talking to. Keep watching the sky. Keep listening, because somewhere out there, a small machine is still trying to reach us. And for now, at least, it still can.